Hello there. Today we're going to be talking about Le Chatelier's principle. Previously we've been talking about equilibrium, and equilibrium is when reactants are producing products, but at the same time the products go backwards and produce reactants. And initially in a reaction, the reactants are going to only produce products because we don't have any products. But as these products get made, those products have enough energy to go backwards and become reactants. And so as the reactants become products, the products become reactants, and as the concentration of reactants decreases, the concentration of products is increasing and becoming reactants. And eventually, the rate at which the reactants are becoming products will equal the rate at which the products become reactants, or the rate forward from reactants to products equals the rate reverse as the products become reactants. And at this moment, when rate forward equals rate reverse, we have equilibrium. And equilibrium is kind of like a seesaw. On a seesaw, you can have one person sitting on the seesaw really far over here, and on the other side, you could have three people, 2, 3, sitting on the seesaw, and they're all, oops, his foot's going the wrong way, and they're all sitting closer to the fulcrum, the pivot point. And this can be balanced, even though there's three people on one side and one person on the other side. This is a balanced situation, or equilibrium, because of the way the weight is distributed. Same thing with equilibrium in a reaction. The reactants can be heavier, or the products can be heavier. In other words, you can have more reactants or you can have more products. But the key is that the rate forward equals the rate reverse. Just like where these three people are positioned allows them to be at equilibrium with the one person positioned on the seesaw on the other side. So equilibrium can be attained anywhere. We could put another person on this side, and that of course would change the equilibrium. These people over here would have to scoot back in order to achieve equilibrium, in order to achieve balance. So when we stress one side of our seesaw, the other side has to respond in order to equilibrium again. And that idea that when you stress one side of a reaction, the reactant side or the product side, and the opposite side responds, is called Le Chatelier's principle. And that's our topic today, Le Chatelier's principle. So let's define Le Chatelier's principle. So here's Le Chatelier's principle. When a stress is applied to a system at equilibrium, the system responds in a way to reduce that stress. So let's think about different stresses you could apply to a chemical system. One stress you could apply is temperature. You can either warm a reaction up or cool a reaction down, and either of those is going to stress a system. It's going to be an applied stress. You're speeding the molecules up or you're slowing the molecules down, and that's going to stress the system. Another thing you could do is apply pressure. And if I could spell, that would be great. Pressure puts the molecules closer together or further apart, increases how fast they're running into one another, and so pressure is a stress. Another stress is by adding reactants. If we add reactants to the system, then that's going to stress the system. So by adding reactants. We could also add products. If a reaction is making products, then adding more of that product externally would stress the system. And then we also could do the opposite of adding. We could reduce. So we could remove reactants. We could take a reactant away, and that would stress the system. Or we can remove products, and that would stress the system. So let's talk about how each one of these would affect the system and how Le Chatelier's principle predicts the system would react. Let's use this reaction as an example for what we want to do. Nitrogen gas reacts with oxygen gas and 2 moles of it to produce 2 moles of nitrogen dioxide gas and heat. It's an exothermic reaction. So let's say in situation 1 we add some extra nitrogen. Okay, we're adding a reactant to this situation. What would that do to the reaction. How would this reaction respond in the presence of extra N2? So if we added some extra N2, which is a reactant, the reaction will not be at equilibrium anymore. It won't be balanced anymore because we've added one of the reactants. And so in order to reduce that stress, in order to get rid of some of the extra N2 that we added, equilibrium is going to shift to the right in order to reduce that stress. So equilibrium will shift to the right and get rid of that extra nitrogen and produce more NO2. And so in this reaction, the added stress N2 will cause the reaction to shift to the right to get rid of that nitrogen. Let's look at another situation. Let's say that into this system, into the container that has this reaction at equilibrium, we add some extra NO2, nitrogen dioxide. What's going to happen now? So now we've added some extra product. An extra product means that it's not balanced anymore. It's kind of like in our seesaw example, where you have different people on the two different sides and they're balanced. Well, if we add something over here, like let's say that this person all of a sudden is carrying a medicine ball. Okay? That medicine ball changes the equilibrium. And so we need to balance the reaction by shifting this person over to the left. In other words, we need to get them closer to the other side in order for the reaction to get balanced again, in order for the seesaw to get balanced again. So when we add NO2, the reaction is going to shift to the left to get rid of some of the NO2 and achieve balance again. So it's going to shift left. It's going to get rid of some of the NO2 and produce some of the reactants. And that will achieve balance again. And again, that's Le Chatelier's principle. Let's look at another example. Let's say that we heat the reaction up. If we heat the reaction up, we need to look at where is heat in this reaction. And you'll notice that heat is over here on the right-hand side. And so if we add heat, if we're adding extra heat, that's a product. And that extra heat is not going to keep the equilibrium. If we add heat, we need to get rid of that extra heat that we've added. So equilibrium is going to shift over to the left in order to achieve that balance again. So it's going to shift left in order to achieve equilibrium once again. Okay? Let's try another one. Let's say that we remove some oxygen from the reaction. So now we're taking away oxygen from this reaction. What will happen? Well, we're creating a void. If there's not as much oxygen, we need to replace some of that oxygen that we removed. And so what's going to happen is the reaction will produce more oxygen. We'll go from the products to the reactants, and so the reaction will shift to the left to replace the oxygen that I took away. So let's look at a summary of one of the things we can tell from these four examples. When we add something, the reaction will shift to get rid of what we've added. So if we added some N2, the reaction will shift away and get rid of it. So the N2 will react, the extra N2, and produce product. So the reaction would shift right. If we add some heat, then the reaction wants to get rid of that extra heat. So the reaction will shift left to get rid of that heat. If we reduce something, if we get rid of something, then the reaction is going to want to replace it to achieve equilibrium again. So the reaction will shift to replace what was removed. So in this case, if we remove some oxygen, we take some oxygen away, we've left a void, and so the reaction will shift in order to replace that oxygen. So the products will shift to make more of that oxygen. If we remove some heat, if we lower the temperature and remove heat, the reaction will shift to the right to produce more heat to replace the heat that we removed. So when we add something, we shift to get rid of what was added. When we reduce something, we shift to replace what was removed. And this is what Le Chatelier's principle is all about. Shifting equilibrium, shifting balance in order to achieve a new equilibrium when stress is applied. So we have two more stresses that we need to look at, and they're a little trickier than the last ones that we talked about, and I think this reaction will show it well. When carbon reacts with oxygen, if you have what's called incomplete combustion, you make carbon monoxide instead of carbon dioxide. In other words, the carbon didn't react with as many oxygens as it normally would. And so in this reaction, you have 2 moles of carbon solid reacting with 1 mole of oxygen gas to produce 2 moles of carbon monoxide gas. And so the tricky question is, what if we add some more carbon? And the question is, what would happen to the equilibrium? Would it shift left? Would it shift right? Or would it shift not at all? And the answer, the tricky answer is, there's no shift. And remember, solids and liquids do not affect equilibrium. Because their concentration is constant, adding more carbon does not change the concentration of carbon. And so if we look at the equilibrium expression for this, K equals the products, which is the concentration of carbon monoxide, squared, because that's its coefficient, divided by the concentration of oxygen to the first power, because its coefficient is 1. Notice carbon's not in there anywhere, because it's a solid. And so because carbon's not in the equilibrium expression, carbon does not affect the equilibrium. So adding carbon does not shift the equilibrium because it's a solid. Same thing with liquids. Adding a liquid would not shift equilibrium. Let's do one more. What if we decreased the volume of the container? In other words, we make the container smaller. If we make the container smaller, that means that there's going to be more pressure on the gas. By decreasing the volume, you increase the pressure. And that means that the molecules are getting closer together. They don't want to be closer together. Molecules want to get as far apart as they can. So by increasing the pressure, we're going to cause there to be a need for less gas. And so we look at this reaction. Which side has less gas? Well, it's the reactant side. There's less gas. Only 1 mole of gas on the left, whereas there's 2 moles of gas on the right. And so in order to decrease the amount of gas, we're going to go from the 2 mole side to the 1 mole side. So when we decrease the volume, reaction will shift to the left. It will decrease the amount of gas present in the container by shifting to the left. And so these are two kind of tricky examples of Le Chatelier's principle. And one is with solids and liquids, and one is about decreasing or increasing the volume. And so you got to be careful of those. So that's Le Chatelier's principle. Good luck with your assignment.